Here we have another example for calculating the reactions. In this truss we have again hinge point at A and roller support at B. Step number one is we need to assume a direction for the reactions. I will assume the vertical reaction for the hinge reaction here to be in this direction, and for the horizontal we'll assume the direction is this, and for the roller we have only a vertical reaction. I will assume the direction for the roller to be upwards, and again for the naming, the name for this will be reaction at B, and the y direction this will be reaction A in y direction, this will be reaction A at x direction. So again, as we did before, we have three unknowns, 1, 2, and 3. And we said the concept or the approach for solution of problems of this type, that we have three unknowns. We said we'll use the equilibrium equations to solve this problem, but we say we always start by taking the sum of moments about a point where two unknowns intersect. So that is the point where we would like to take moments, because in this case what happens is we'll cancel out this unknown and this unknown. This will be the only unknown we have in the equation, which will make our equation easy to solve. And once we calculate again the value of RBY, then we use the very same concept that we followed in the previous example. Next will be by taking the sum of all forces in y direction, we'll calculate the value of RAY. And once we calculate the value of RAY, we do all forces in the x direction to calculate the value of RAX. So let's start the solution once we know this is the approach for our solution. So as you know, we have to resolve the inclined forces to x and y direction and make sure that we have the perpendicular distances to the point of rotation. Let's start with F1, and F1 will be resolved into its x component. Of course, and my sketch here, I'm showing the line not to be exactly on top of this line of the truss, because I just want to show you that this will be resolved into two components, component x, and this is the component y, but normally these lines align with the same element of the truss. And let's name them also. So this will be F1x, this will be F1y, and same story is for the F2. We'll have an x component, which is this one. We'll have a y component, which will be this one. I will name them again. This is F2y and this is F2x. So now that once we have resolved the forces, of course the value for these forces is something we covered in the previous lecture. So all I do is I'm going to say, of course, F1x, you know, this angle is, this force extends. If I do this, then this angle will be same as 38, and the 70 for F2 is already clear, so I don't need to it is straightforward, I don't need to do any clarification for that part. So I will just go ahead and do the values for F1x. So F1x will be equal to 25 cosine 38, 25 cosine 38, and that is equal to 19.7, and F1y is equal again 25 sine 38 degrees, that is equal to 15.39. Of course, kilonewton, the units for both of them. And for f2x, the value will be equal to 22. You do the math for this part. That is will be 65 cosine 70, and for f2y will be 65 sine 70, and that is equal to 61.08 kilonewton. So now once I have the values for these components also, so all I need to do is I need to define the rotation for each force. And this question we are talking about moments about point A. So starting with F1x, F1x is passing through point A, so it will make no rotation. If you see, this is passing through, so it will make no rotation because there is no perpendicular distance between the force F1x and the point A. So there is no rotation for F1x, but F1y will rotate in this direction, which is clockwise, so negative, and F2y will rotate counterclockwise, which is positive, and F2x again will rotate counterclockwise, which is also positive, and F3 will rotate clockwise, which is negative, and F4 will again rotate clockwise, which is again negative. RBY will rotate counterclockwise, which is positive. So once we define these directions, we should apply them to our equation. This equation will have the sum of moments about A is equal to 0. That is the equilibrium equation. So let's start with F1y is negative. F1y is equal to 15.39 kilonewton, and the perpendicular distance between F1y is equal to 6 plus 4, which is 10, multiplied by 10 meters. Then F2y is positive plus, and F2, the value for F2y is equal to 61.08 kilonewton, and the perpendicular distance between F2y and this point is equal to 4 meters. 4 meters. And then F2x again is positive, so plus, and F2x is equal to 22.23 kilonewton, and the perpendicular distance between is this, which is equal to 4 meters again, 4 meters. Then we move to F3, and F3 is rotates negative, so minus. F3 value is equal to 30 kilonewton, and the distance between F3 and the point is again 4 meters, so multiplied by 4 meters. Then F4 is rotating negative, is 48 kilonewton, multiplied by the distance between is equal to 6 plus 4, which is equal to 10. 10 meters is equal to 0. So once we isolate the only, and then sorry, we forgot the, then we have the RBY. RBY is rotating positive, so plus RBY multiplied by distance between RBY, and this point is 6 plus 4, which is equal to 16, multiplied by 16 meters is equal to 0. So from this equation, it's clear that we have only RBY to be unknown. Rest of them are known to us, so we just punch in the numbers to calculate, and once you isolate the RBY will be equal to 420.6 0.66 divided by 16, and the answer for RBY is equal to 26.29 kilonewton. And because the result is positive, so it means that the assumed direction for RBY is correct, and that is upwards. That is for RBY. Okay, now that we calculated the value of RBY by taking the sum of all moments about point A, now we still have two unknowns left, which is RAY and RAX. We will use the second equation of equilibrium by doing the sum of all forces in y direction equal to 0. So with this we have RA is positive plus RAY is in the upwards. We have F3 is downwards minus F3. We have plus F2y upwards. We have F1y is downwards minus F1y, and F4 is downwards minus F4, and RBY is upwards plus is equal to 0. Now we substitute the values. Of course, RAY is the unknown plus RAY, and the F3 is equal to 30 kilonewton, and F2y is equal to 61.08, and F1y is equal to 15.39, and F4 is equal to 48, and RBY we calculate RBY is 26.29 is equal to 0. So once we isolate RAY, we get the value of RAY is equal to plus 6.02 kilonewton. It means that the assumed direction for the reaction is correct, and it is upwards. Now that we calculated the value of RAY, we'll move on to calculate the value of RAX by taking the third equation of equilibrium. We'll use sum of all forces in x direction equal to 0. And this one we have RAX is going east, which is positive, RAX. And we have minus F2x. And we have minus F1x. And there is no other horizontal force, so is equal to 0. So RAX is the value that we are trying to calculate, and F2x is equal to 19.7. Sorry, it is not. It is equal to 22.23, and F1x is equal to 19.7 is equal to 0. So if we isolate RAX, we get the value of RAX equal to 41.93 kilonewton. That is the answer for the question. And because again the result being positive, it means the assumed direction for the force is correct, and it is towards east. That is the final answer for the question. كيف خواتكم؟